So when you're doing a recalibration, shoot for the bullseye, not the target board. In one of the last videos we did, I mentioned how I was going to lay out something in a visual representation of why I think calibrations should not be done in parking lots, why they should be done in shop, in a controlled environment. And I would even make an exception to maybe, let's say you've got a good slab that's outdoors that is also a controlled environment, where you know you've got a good flat level floor to work off of and a good base to work off of in order to get your target in the proper position. I think there's an exception for that, but just in parking lots randomly or some shop with junk floors in it, I think all of that should always be avoided. I think it's dangerous for the consumer, but also the shop and the technician that's performing the job. If something goes wrong with these systems and there's a collision due to a camera not being calibrated properly, then the amount of liability associated with that is just outrageous. We're talking about sinking businesses, technicians being personally liable, just like any other portion of the automotive field. So I'm not an artist. I do apologize. But I laid this out the best way that I could to explain the variance that may occur while you're performing a recalibration, maybe even with a stand that's or a piece of equipment that is not set up, that has targets and laser measurements, basically something where you're pulling lines on the floor or tape measures. There's a lot of variance that can happen and a lot of operator error that can occur on the technician's part while trying to perform that function. I want to put an emphasis on when you're calibrating a camera on a car, you're not looking for a pass or fail. Too many people in our industry are looking at this as a pass or fail. And something I'm hearing more recently in some of our circles is people are referring to something they're calling a false positive, that false positives don't exist. And I agree with that to a point, because if you have that target set in such a position that it's anywhere inside of this target bubble, then it will pass. But that does not mean optimal. Our goal is to try and get that camera and that target in the most perfect neutral position as possible, so that that camera can perform its duties to function with all the variables that is programmed for it to function with from the factory. So, and to explain those variables, no vehicle is perfect. Everything is different slightly. Vehicle heights are going to be different. Hub center lines are going to be slightly different. It can't be manufactured absolutely perfectly. There's variance from car to car. Windshield position in the body of the car, there's going to be some variance there. Camera position on the windshield, there's going to be some variance there. I don't care if it's OEM or aftermarket. There is going to be variance from windshield to windshield, and that's the exact reason that every time you have a windshield replaced, you must have the camera recalibrated. Now, this is going to apply, my demonstration here is going to apply specifically to vehicles that require static recalibrations, not vehicles that require a dynamic. Now let me break it down for you, the two differences between those types of calibrations. A dynamic calibration is mostly found on domestic windshields or anything that's made in the United States, American-made companies, or American-based companies, and some European companies, like Rover does this on some models, maybe all models. BMW does it. I think Volvo also does it. They do dynamic recalibrations, which is basically I hook up to the car with a tablet and I put it in, I go into the forward-facing camera module or the IMPA or whatever your specific manufacturer calls that camera module. Either way, it is the camera that's attached to the windshield or the roof of the car that peers through the windshield to detect your lane, lines in the road, signs, anything like that. A dynamic, so I come up, connect to that forward-facing camera through a diagnostic tool, and and put it in calibration mode or a learn mode, and then we take it out and we drive that car, and it uses the lanes on the highway, the sign, speed limit signs, stop signs, anything that you're passing on the road, that it can consume that information to tell that camera, that module, its position in the world around it. When we're doing the recalibration, we're telling that camera its position of the world around it relative to its mount. So dynamics can be done mobily. That is perfectly acceptable. It's industry standard. Statics, in my opinion, must be done in shop in a controlled environment where we can control those variables to make sure that camera is precisely where it needs to be, or we can at least tell that camera what variables about that camera may be off from dead zero that was attributed to it from the factory. So the type of variables here, there's a couple other variables. There's lighting, there's a couple other things that may affect us doing a recalibration. But the 5, I think, most crucial ones that I want to hit on is going to be height, pitch, roll, offset, and yaw. Now, I'll describe all these for you. So height is going to be the height of that camera relative to the ground. Roll is going to be, say that camera's looking at you. If the camera is rolled slightly this way or that way. Pitch is going to be, so say the camera's looking at you and it's either going to be pointing down or pointing up. Another good way to think about this is the pitch of a camera will be altered if a vehicle is squatted or leveled, or any sort of suspension work has been done where the front and the rear of the vehicle has been altered at different heights from each other. So if you lower the rear 2 inches, or if you got these goofy trucks that are running around squatted. Yaw is going to be parallel to hub center. So the best way I can think to describe this, let's say you've got your car and you've got wheel, 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 wheel. What we call hub center is where you draw an imaginary line through the center of each hub on that vehicle. And then you've got, say the target is set at, we'll use like a Toyota Lexus example, 1,350 millimeters in front of this car is where that target position is going. And say the target parallel line is here. Yaw is going to be the difference between these 2 points and these 2 points. So in other words, if I've got the target in front of the camera, yaw is it's the camera variance or the target variance in this direction or position. A camera will recalibrate if all of these variables are in a position at which it allows that camera to target position to be somewhere in this big bubble. All right. Now, just because it's in the bubble doesn't mean it's accurate. It doesn't mean it's right. It's no different than you've got a firearm, and the firearm, you zero a firearm optic at 25 yards, and it may be dead on MOA at 25 yards. But you go out to 100 yards, and it's 3 inches out. You know, what may be a half inch out at 25 yards may translate to 3 inches or 6 inches at 100 yards. As you get farther out, the variance in the calibration of that is farther away. So just because it lands in the circle and it passes doesn't mean it's right. You're shooting for target optimal position right here, which is dead center, which is what the factory intended it to be, and then you correct for as many variables that you can to tell that camera, hey, this is the position you should be in, and here is your operation window inside of this bubble that you're allowed to have in order to function. So when you're driving down the road, the height of that vehicle is constantly changing from the bumps you're hitting. The roll of that is constantly changing back and forth if you hit a bump on one side or the other. The pitch is going to change depending on suspension collapse, front to rear, if you're on a hill, or if you have a load in the back of a truck, you have a load in the back of the car, it's going to change from your fuel tank being full or empty. That causes variabilities in pitch, but also roll of the camera. There are variabilities in all of these metrics while driving that car. So your goal, get it in the center and allow that camera to be inside of this operation or range of operation in order to function properly. So now into breaking down why I think this should be done in shop in a controlled environment and not in a parking lot somewhere. So in a parking lot, you can't control for variables such as like height. I'm sure there's probably a parking lot somewhere in this country that's got a perfectly level surface. I'm sure the odds have happened in such a way that that's the case. But the overwhelming amount of cases, I would say almost 100%, there's going to be variability in the blacktop or the concrete in that parking lot. You know, as you go across that parking lot, there's going to be high and low spots. And you've got no way to tell how high the high spots are and how low the low spots are. So when you're setting target height and you're not using a stand that's got cameras and targets on the wheel, hub center line and stuff, where with a more advanced targeting system, you're determining camera height based off of relative position to the car. Whereas in a parking lot, you're going from the ground up. So let's say the vehicle is offset from the target. You know, you got 1,350 millimeters from the target face to the hub center line or the center of the front bumper, you know, like the emblem of the front bumper. And say there's 5 millimeters or 10 millimeters or 20 millimeters worth of unlevel surface between the car and the target. If that's off at all, what you're doing is, say this height moves your position away from target optimal position. If the target's super high compared to the relative position of the car, it's going to put your calibration position farther to the outside of this operation window, and then as well as the other direction. So both of those are bad. We want to ensure the most accurate input possible. But all of these things, so height, pitch, roll, yaw, offset, all of it has variables depending on the lot that you're in. And you have no way to correct for those factors without advanced equipment. Maybe someday somebody will come along with something, and I think we're probably closer to this than not, where there will be tools that accommodate for these differences and allow you to do these things mobily. But right now I don't see it. And even from major players in the game, you know, people that are manufacturing equipment to be able to do these recalibrations, I'm seeing some really nice equipment, but none of it is set up in such a way to compensate for massive level and unleveled surfaces on a mobile recalibration. This applies to a shop floor. Let's say you've got a shop floor with a terrible slab. So if that slab is terrible, it's just as bad. Now it makes it so you can correct for it if you understand. If you're in your shop every day doing recalibrations, I know that I've got a 3 millimeter low spot between my stand and where the car is normally set over there. I can correct for that factor. I know it's there. I've been doing it long enough. I can move it from one portion to another, and I can see the low spots in the floor with a tape measure to the floor, with a laser to the floor. So I can accommodate for those things. So when you're doing a recalibration, shoot for the bullseye, not the target board. You should be doing this to the best of your ability every single time to ensure your customer safety, the safety of the family of your customers, and the safety of the other drivers on the road that your customer may hit because of a system not functioning properly. Now, if this goes in your favor 99 out of 100 times, there's that 1% chance that you have a customer that's going to be involved in a collision or an accident because of that system not functioning properly because you shot for the window and not the bullseye. So at Glass Express, we prefer to do everything in-house. We think that is not only the best way to achieve the results that should be achieved, but the only way at this point in time to achieve that result accurately. So you can feel free, stop by at 820F Paris Island Gateway over in Beaufort, South Carolina, zip code 29907. Shoot us a call at 843-379-7222. We'd be glad to further expound on this if you've got questions, or put some comments, questions, anything you may have down below in the comment section. You know, if there's anything else I can expound on here and address about this, I would love to dive into it, you know, deeper to try to farther explain this. This is kind of something I just kind of put roughly together in my head and put it on paper and, well, on a whiteboard. I hope it makes sense. I hope I was able to answer some questions people may have and inform you as a consumer, or anybody that is a consumer, on how to select a shop that is going to do your windshield replacement and camera recalibration accurately the first time. Thank you.